just gonna record this session, and this is basically a live Zoom tutorial session for the Cambridge International 5129. This is the combined science chemistry questions for the June 2021. This is paper 1-1. So it was what I have sent you via the WhatsApp chat group. And I told you should continue the rest of the question yourself. But what I'll do is I'll now go through the questions live instead of sending you the videos. So this session I recorded anyway. So whatever that is recorded will be shared via the chat group in a little bit. So question 14, so we have a condenser. So you can think about this condenser is the hot vapor will come in. It's called hot vapor because it's a gas that boils. So you have a solution mixture. So in this solution mixture, it's going to go into the gas because this is distillation. So you boil the solution mixture, and it involves boiling or evaporation. That is your first step. Evaporation, or you call it boiling, changing into the gaseous state. Then what happens is the hot vapor comes in here, and the cold water. So this is water in from the bottom, and then water out from the top. So what happened then is the hot vapor will condense. So the second process is called condensation. This apparatus is called a condenser. So boiling is from liquid to gas. Condensation is from gas to liquid. So what comes out is liquid. And that is what you collect there, okay? So the hot vapor is going to come in at P and not Q, because Q is where the water goes out. And then the cooling water, where does that enter? The question is enter. Enter means come in. So the cold water coming at the bottom, and the water goes out from the top. So we have R, the cool water comes in at the bottom there at position R. Question 15. So which statement describe the changes in kinetic energy? Kinetic energy means movement energy. So what do we know about kinetic energy? As we heat it through 5 degrees Celsius, and then they become a liquid. So this goes back to your year 9. This is your first topic in year 9. As time progresses, what happened on the y-axis, you're gonna get change of state like that. I'm not gonna draw the whole thing, well, actually I'm gonna draw the whole thing like that. As you know, that is what happened as you heat through the 5 degrees Celsius. This is not specifically water, it's just based on the information. And then they change the state to become a liquid. When you become a liquid, this is your melting process, the one I've highlighted in red. So that is your melting, that is solid to liquid. During melting, you have both the solid as well as the liquid. But then after you melt, that means this one in green here, that thing is going to be liquid because you have already melted. Okay, in Malay it's called cair. You're already cair, so you're already a liquid. Here you are just going to start melting, and that is what they're trying to make you imagine. You're going from solid, which I'm going to highlight in pink. So pink there is your solid. From solid, melting, and then to become liquid, there's your change of state there. As you can imagine also, if you're asked to draw a diagram like that, nope, don't want that. So as you draw a solid, you will draw a solid being tightly packed. So tightly packed because they are kind of touching each other. And then as they go to liquid, they will have a bit more space in between, but not like very far apart. They are still quite closely packed. It's just that there's a little bit more space in between. Just now, you only vibrate as a solid. You vibrate about fixed position, whereas that is for solid. But then when you are liquid, you can slide, S-L-I-D-E, slide past each other because now liquid particles have a little bit more space in between. Now we are heating it through 5 degrees Celsius. So what we're doing is we are going this way. So we are absorbing energy. As you provide heat, the particle will absorb energy, they'll absorb heat energy, and therefore there's converted from heat energy that you supply into kinetic energy, because this particle from solid to liquid to gas, they move faster and faster. That's because they gain kinetic energy. So talking about losing kinetic energy is definitely wrong. So A is already out. Then it says they move faster. They move faster from solid to liquid. So slowing down is definitely wrong already. So I can cross out D. Now they fill up the available space versus they remain bunched together. Bunched together refers to how they are packed. As you can see, they are tightly packed, so they are bunched together. Here, there's a little bit more space in between, so they are no longer bunched together. They are like liquid. Liquid can fill up the available space because liquid take the shape of container. If you think about water, if you have a different shape water bottle, then you pour the liquid into the water bottle, it will follow the shape of that container. So liquid will fill up all the available space, shape of container. Should spell that properly. Okay, hence the remain bunched together is definitely wrong, as there's for solid. So we'll look at option B there. Question 16. So this is definition of isotopes. This is in year 9 atomic structure. You should have a book of definitions that you make up your own notes as you go through all the topics for chemistry, for bio, as well as for physics. And you will prepare this definition so that you have a look at it every day. Isotopes are defined as atoms of the same element. So there's the first bit to the definition, atoms of the same element. If they are the same element, that means they must have the same proton number, because you are the same element, you are the same identity. So same proton number, but something is different. What is different is different mass number, or you can say different nucleons, and therefore different mass or nucleon number. That means different number of neutrons. Do not confuse nucleon and neutrons. There's number one confusion. In your periodic table, this is what will be shown for you. For instance, carbon will be shown as 6 on top and 12 at the bottom. Your periodic table tells you there's atomic number, and it tells you there is relative atomic mass. That is given in your periodic table. So what happened then is you also have it in your international standard. The one that exam question always give you is not the same as periodic table. They always show you on the far left-hand side, sebelah kiri, okay, left-hand side. So what happened then is, that this is proton or atomic number, whereas the one on top now is what you call mass, or you call it nucleon number. Nucleon number is the number of protons plus the number of neutrons. So what happened then is, we know isotopes have different number of neutrons. That is the definition of isotope. Well, same proton number, but different number of neutrons. So looking at the first option there, same number of electrons and neutrons, same number, definitely wrong. A is already wrong because it says same number of neutrons. B, same number of neutrons, that's already wrong. C, same number of protons, yes. Different number of neutrons, yes. C is our answer. Let's have a look at D, same number of neutrons. Again, that is wrong because same number of neutrons there. So D again is wrong. Number 17, which statement about the formation of negatively charged ion is correct? Negatively charged ions, correct, okay? So from what I've done in the bunch of paper I give you for periodic table work, and I only managed to go through part 1 of it. All the tutorial videos are already online, so you can watch through that a playlist of videos that I shared previously. So on the left side of the periodic table versus the right side of the periodic table, you have group 1, 2, and 3, which you consider them as metals, and then 4, 5, 6, 7, those are your non-metals. Now, what do we know about the metals? The metals will lose electrons. I think about the L and the L, the left-hand side lose electrons. When the metal lose electrons, you get positive ions. On the other hand, when the nonmetals gain electrons, they accept electrons. Electrons are negatively charged. When you get negatively charged, you form negative ions. Now, which statements about formation of negatively charged ion is correct? They are formed by elements on the left side. That is wrong. It's the nonmetals on the right side that will gain electrons. You don't really have to write all this down, but you gotta be able to read the questions and cross out what is impossible based on what you know from your concept. So A is wrong, you want correct. They are formed by metallic elements. Metallic elements is on the left side. They are formed by non-metallic elements, so B is wrong. They are formed when atoms lose electrons. Electrons are negatively charged. When you lose negative charge, you become positive charge. If you want negative charge, you must gain negative charge. You must gain electrons. So lose is wrong. It should be gain. So C is wrong. They are formed when halogens become halides. Halogens is a special name given for group 7 element. Halogen molecule. Halogen molecule refer to X2 such as CO2, Br2, I2, where CO2 is a gas, Br2 is a liquid, I2 is a solid, because down group 7, your melting point increase, your boiling point increase, as you imagine gas, liquid, solid going down group 7. When they become halide, is an X minus ion. You imagine chloride, bromide, iodide. This is again a year 9 concept as part of atomic structure, as part of chemical formula. So from the atom, from the molecule, they will form the atoms. From the atoms, they will gain 1 electrons to become completely filled out the shell. Example, chlorine atom will be 287. So that will be your first shell, your second shell, and then there is your third shell. Because it's a period 3, it's the third row of the periodic table. It's in group 7 because it's got 7 outer shell electrons. So that's group 7. So what happened then is it will gain 1 electrons in order to get to a stable ion. This is stable because fully fill out the shell. This is fully fill out the shell. These are very popular exam questions in theory paper. We call it fully valence, V-A-L-E-N-C-E, or if you don't like valence, you can use the term outermost shell. So now it's a -1 charge because you gain 1 electrons. From 7, you become 8 electrons. So definitely D is the correct answer. I already got the answer by crossing out what is impossible. I was just showing you all these things to recap your year 9 combined science chemistry concept, which of course you have in your notes. You have done it in your year 9 end of year. You've seen it in your year 10 concept. You've also seen it in year 11 again and again and again. Question 18, which statement about covalent bonding is correct? So you want covalent bonding. So we know that metals just now lose electrons and you will get positive ions. So the fact that we have positive ions there, and nonmetals on the right side, they gain electrons and they form negative ions. So when we have positive ions and negative ions come together, I get ionic bond, I get ionic compound. On the other hand, if I have nonmetal and nonmetals, instead of forming ions, I will have atoms, not ions, and they will share electrons. Here I get a transfer of electrons. Whatever you lose, you give the electrons to the nonmetals. So what you get there is transfer of electrons from the metal to the nonmetals. You get ionic compound, ionic bond. When you share electrons, you get something called covalent. Covalent, I better spell that properly, C-O-V-A-L-E-N-T. You get a covalent bond, you get a covalent compound. Now these are properties. Based on the properties, covalent compounds are what you call insulator. They do not conduct at all. And you can say low melting point and low boiling point. Ionic compound, on the other hand, does not conduct when solid. So the solid does not conduct, but it can conduct when they become liquid, when the ions are free to move, or when they are in aqueous solution, meaning when you dissolve it in water. What is very important is these properties are always asked in multiple choice questions as part of bonding, and they are also very, very popular, such as these questions in structure question as well. Okay, based on what I said, covalent compounds do not conduct, so good is definitely wrong. It should be poor. A is wrong. By sharing outer shell electrons, covalent bond is formed when the non-metal and non-metal share electrons. They share their outer shell electrons, so that is correct. Covalent bond are formed between metals and non-metals. There will be ionic for metal and non-metals. You get transfer of electrons. Non-metal and non-metal form covalent bonds. So covalent there is wrong, should be ionic there. C is wrong. Nitrogen form 5 covalent bond with hydrogen. That is clearly wrong. Nitrogen has 5 valence electrons. Hydrogen has only 1 valence electron. So what you get is nitrogen dot cross with hydrogen. That is a single covalent bond because there's 2 electrons being shared. And then another covalent bond and another covalent bond. I use only 3 out of 5 for covalent bonding, so I must know how to count and complete my outer shell. In my nitrogen outer shell, I started with 5 crosses, and I share 3 electrons from 3 hydrogen, 1 dot, 2 dot, 3 dot, 5 plus 3 give me 8 hydrogens in the first shell. Fully filled is 2 electrons, 1, 2, 1, 2, 1, 2. So it's not 5 covalent bond, it's 3 covalent bonds, as I can draw it like that. Okay, that's all the time we have for this tutorial. It's now 10:19. You should move on to your break. And this lesson finished at 10:20. So thank you for joining me. I'll just quickly take a screenshot of everyone who is present. And yeah, thank you for joining me. And I'll stop sharing now. And I'll share the video in a little bit. Okay, see you guys. Have a good day.